So in this chapter, we are going to learn about the exploratory data analysis, which is based on the statistics. Okay. So we are going to learn at least two things. First is the exploratory data analysis, and the other is basic statistical description of data. Okay. So first, what is exploratory data analysis? We call exploratory data analysis because we want to apply some data analysis to explore. Okay, the word exploratory means to explore, and usually it is used by the data scientists to analyze and investigate data set and summarize their main characteristics. So we want to make the summary before we do further analysis. So there are at least three basic concepts. Okay. Before that one, usually the EDA will include data visualization. Okay. So there are at least three basic concepts. The first is to understand the variation. The second is to understand the typical values. And the last one is to understand the unusual values. If we want to understand the variation, so this is the data from the iris data set. So last lecture, we learned about the iris data set. If you still remember, we have the petal length, and then we have petal width, and then we have sepal length, and then we have sepal width. Okay. And we can see from three kind of flowers. Okay, we have the iris setosa, iris versicolor, and iris virginica. Okay. And you can see that the blue color, okay, the blue color is the iris setosa. Maybe the text is very small. Okay, so the blue color is setosa. What about the orange color? The orange color is iris versicolor. Okay. And then the red is the iris virginica. Now, you can see if you apply this plot, okay, if you apply this plot, you can easily distinguish. I can see that the petal length for the setosa is smaller than the other flower. Okay. So we can understand the variation easily based on this visualization. So usually the visualization will include many kind of chart like bar chart, scatter plot, yeah, line chart, pie chart, histogram, heat map, and etc. So we will learn. Hopefully we can finish all by today. Okay. So this is the scatter plot. Okay. So here we use the scatter plot to understand the variation of the data. Okay. So the first is the variation between petal length and petal width, and then this is the variation between petal length and sepal length. This is the variation between sepal length and petal width, and so on. Now we can also use another kind of chart, for example, histogram. So using this kind of histogram, we can also understand that the petal length mostly for the iris setosa are very small, but for the versicolor and virginica is higher. Okay. And you can also see from the sepal length, the sepal width, and the petal width. With that variation, of course, yeah, now it's obvious, but some data might not be obvious like this one. So you need to do more things. For example, okay, I want to know based on the box plot. Okay, so today we are going to learn also about the box plot. Then you can see if it is the box plot, yeah, iris setosa is very low, and versicolor is in the middle, and the virginica has the longest petal length. Okay. So this kind of variation is important before you do the data mining. Okay. When you do with your EDA at the first time, you can also find the typical values. What is the meaning by typical values? Yeah. So we want to understand which values are the most common and why. Okay. So if we are using histogram, so we can see the frequency. Okay, there are many flowers in blue colors, which is setosa. Okay. So the blue color is the iris setosa. So the blue color with the petal length, there are more than 25 flowers with the petal length is in between 1 until 1.5. Okay. And you can see here the petal length of the iris versicolor with the iris virginica. Yeah, because we have the orange and red color at the same time, so it is the stacked histogram. So we can see they are the most common value after this one. And we can also see which values are rare. Okay, maybe this is the rare value. This is the rare value. And why? Does that match your expectation? Can you see any unusual patterns? What might explain them? So yeah, you can use this kind of things, the visualization, to answer this question. Maybe the first thing is the understanding about the typical values, and the other understanding is how to find the unusual values. The unusual value, for example, oh, this is very unusual. And yeah, we want to find the data points that do not seem to fit the pattern. So you can see that the petal length, yeah, here, the petal length of the blue color is very small, but the sepal width is very huge. Yeah. So yeah, based on this one, yeah, you can see like it's not that usual. If the flower is small, maybe we can say that yeah, the flower length for the petal and the sepal should be almost similar. But okay, this is a little bit interesting. Yeah. This is a little bit unusual because the frequency is also very small. Or we can say this is outliers. So is it possible with these outliers, or is it because of the data entry errors? Yes, something like this question will be important for you to analyze further. So if you are in the early stage of the data analysis, you will have three basic questions. What are they? So we want to understand the variation. Okay, and we want to understand the typical values, and we want to understand the unusual patterns or unusual values. So we can just say that how can we understand the variation, how can we understand the typical values, and how can we understand the unusual values or unusual patterns. Okay, so based on this one, yeah, you can do more with the EDA. Okay, so let's move on to the basic statistical description of data. When you do the EDA, there should be some numerical expression, or there should be the statistic description about the data. And the motivation here is to better understand the data by looking at the central tendency, variation, and the spread. So using the statistics, yeah, we can understand the variation, or we can understand the typical values, we can understand the unusual values. And some characteristics in the statistic, like median, maximum, minimum, quantiles, outliers, variance. So we will learn about 5 number summary. And maybe we will check also the dispersion analysis. Okay. So in the box plot or the quantile analysis, yeah, we can see the dispersion. What is the meaning by central tendency? Okay. So the central tendency we can see from 3 different measures: mean, median, and mode. So we will check one by one about this one. Let's say I have this data. Okay. So this data will have like somehow 200, okay, so 200 and 450, and then 300, and then 1500, and then 700 and 44. Okay, so this is like the distribution. Okay, so maybe this is the 1 until 5. Okay, and then this is the 6 until 15, and so on. So if you want to draw the line, it will be something like this. And yeah, this is based on the data. But if you revert to the theory of the statistics, if we have the symmetrical distribution, then the mean, the mode, and the median will be almost similar in the same place. Okay. But if it is asymmetrical distribution, then the place will be a little bit different. So maybe the mean will be higher, the median will be in the middle, and then the mode, yeah, will be on the left. Okay. So in this case, yeah, we need to use those 3 measures in order to find the central tendency, because our data might be asymmetrical. If you take a look on the mean, okay, what is mean? You know, average. Okay. When you are calculating the average, yeah, it is just how to accumulate. Let's say I have the data 2, 3, 5, 4, and 6. Okay, then how can we get the mean? 2 plus 3 plus 5 plus 4 plus 6, and it equals to 10 plus 10, 20. Okay, and then What is the average? It is 4. Okay. So with this kind of simple mean, yeah, you can have this number for the mean. But what is the meaning by sample and population? Let's go back to the iris dataset. Okay. So in the iris dataset, we have 3 kind of flower: setosa, and then virginica, and then versicolor. So we have 3 set of flowers, and we call it, this is the population of the data. If I want to know only the mean of petal length from setosa only, so we can see this is the sample size. Okay, so this is the population. So from all the data, yeah, I can group by the data into the sample. What is the sample? Yeah, for this case, I would like to see the mean from setosa only, or I want to see the mean from the virginica only, or I want to see the mean from versicolor only. So we call this is the sample size mean. There is another kind of mean, we call it weighted arithmetic mean. So we can put weight. What is 가중치? Yeah. So one instance might be more important than the other instance. Or we can also find the trim mean. It means we want to chop extreme values. Do you know what does it mean by chop? Chop means we want to cut. Okay. So here we want to remove, this is extreme value. So we want to remove this extreme value. Okay. And then we want to focus only the data that is in the range of these normal values. Okay. So these normal values will be calculated, and then we want to find what is the mean. Median. What is median? It is the middle value. Okay. So this is the formula to get the median, but I guess you know how to calculate the median. Let's say I have a number like 2, 3, 5, 6, 4, 5. We know that the mean is 4. What is the median? In this case, what is the median? Yeah, you can type on the chat if you know the answer. 4. Okay, thank you. That's good. So it means you already know how to get the median. First, we need to sort. Okay. After we sort the values, then we can find the middle value, which is 4. Now, why we need to calculate the median? Let's suppose I have another kind of data: 2, 3, 6, 5, 4, and 1000. Okay, what is the mean? So 10 plus 5, 15, 15 plus 10, 1000. So 1015. 1015 divided by 5. Then it is 203. Okay, the mean is 203. But what about the median? Yeah, it's the same. 4. Okay. So what you can see from here, when we use the mean, when we use the average, if your data contain noise or if your data contain outliers, the result might not be represent your analysis. Okay. Actually, this is something that you will do more with your data mining. Oh, if the mean is 200 and the median is 4, then I would like to remove some outlier data. Okay. Okay. Then, you already understand. If we have the data, for example, 2, 4, 5, 6, 3, and 7. What is the median? Five. 4.5. This one is correct. So first we need to sort the data. 2, 3, 4, 5, 6, 7. So we have 6 numbers. In order to find the median, we need to find the mid value. In this case, because we have the even number, so we have 6 numbers. So we will do the 4 plus 5 and divided by 2. Okay. So that's why this formula is the general formula in order to fit whether the value is even or odd. What is it? Hulsu, chaksu is different. Okay. So this is the whole formula. Okay. Thank you for your participation. So we can also see from another perspective of the central tendency. We can see from the mode. What is mode? It is the value that occurs most frequently in the data. They can be unimodal, bimodal, or multimodal. In the unimodal, you can see that there is only one top, or the highest frequency is only one. But if we have two highest frequency, we call this is bimodal. If we have 3 highest frequency, then we call it maybe 3 modal and etc. We can just say as multimodal. We can express the formula something like this one. So if we have the mean minus the mode, it will be the same with 3 multiplied by mean minus median. Okay, so this is the kind of the formula to see the relationship between mode, and median. Okay. And when you do with your histogram later, you need to understand also how the data is symmetric or asymmetric. Okay. If the data is symmetric, you know that all the mean, median, and mode will be in the same values or almost in the same values. But if it is asymmetric, we can separate into two, whether it is positive skew or negative skew. In the positive skew, so the data is shifting on the left. So we have a lot of data which is a smaller values, for example. But in the negatively skew, we have more data that is higher values. Okay, so we have positive and negative skew. When you measure the dispersion of the data, we can include something like the box plot. So we call the box whisker plot like this. Okay. In the box plot, yeah, there are some statistical words that you need to understand. The first is quartiles. So in the quartiles, we have Q1, Q2, Q3, and so on. Yeah, maybe I just want to remind you. Yeah, maybe you already got the statistics class. Yeah. So in the statistics class in Tongge, you already learned about the quartiles. We have the Q1 is 25% percentile and the Q3 is the 75 percentile. And we can have the interquartile range. So the IQR or the interquartile range is Q3 minus Q1. In the 5-number summary, okay, when you want to check your data, it is good to show the 5-number summary, which is minimum, Q1, median, Q3, and maximum. So the box plot, actually, it is a box. Okay? So some literatures mention it as box and whisker plot. So the box plot or the box and whisker plot, the ends of the box are the quartiles. Okay? So this is the quartile. The median is marked. So we have the mean here. So the median. And at the whiskers, what is whiskers? The whisker is this one. Okay, this is the whiskers. And we need to plot the outlier individually. So this is the outlier. What is outlier? The outlier usually a value higher or lower than 1.5 multiplied by the IQR. And this IQR is from this one. Okay. So if we take a look on the distribution like this one, okay. So the median is in the mid, and then the Q1 here, the Q3 is here. So this is the minimum, this is the maximum. And we call this is the IQR, interquartile range. So if you want to do like the trim min, you want to chop, usually we can do the chopping from this one, yeah, and we can chop from this one. You can also understand the variation of the data from the variance and standard deviation. Okay. The same what we already checked from the mean. In the standard deviation, we have the sample and we have the population. Okay. So the sample means I want to know only the data from Setosa. So if I would like to find the variance of Setosa, yeah, you can just measure with this formula. Okay, so I think I don't need to explain this one. You already know about the variance. If you want to check the population or the standard deviation, so it means you want to use all the data. You want to use the Setosa, Virginica, and versicolor, and you can get the standard deviation. And yeah, we can see the standard deviation with some variance if we have the mu. Okay, so this is the mean from the population. We can have the one standard deviation. This is the range, or the 2 multiplied by the standard deviation, or 3 multiplied by the standard deviation, or we call it like 6 sigma. Okay. So you already know about the Boxplot analysis. Okay? So in the Boxplot analysis, we have the 5-number summary. So the minimum, median, maximum, including the Q1 and Q3. Okay? So the box plot is represented by the box. Yeah, you can I already explained to you before. The ends of the box are the first and the third quartiles, and the head of the box is IQR. Okay. The median is marked by a line with the box. Okay, this is the median. This is the quartile. This is the upper quartile. And then whiskers are the 2 lines outside the box extended to minimum and maximum. Okay, so this is the lower extreme and this is the upper extreme. Outliers are points beyond a specific outlier threshold, and it is usually plotted individually. Okay. So if I have like this box plot, okay, so this is the whisker line, okay, and then this is the outliers, this is the median, okay, and this is the Q3, this is the Q1. Okay. Usually we will handle only with the normal distribution data. Okay. So as I mentioned to you, the normal distribution can be distinguished into whether the normal distribution for one variance, one standard deviation, or the normal distribution with the 2 standard deviation, or the normal distribution with the 3 standard deviation. So if we include only one standard deviation, yeah, the value may be just the normal one in the range of the mean. But if we have the 2 standard deviation, the range is higher. And if we have 3 standard deviation, then we will include almost all the data. We can have another kind of statistical description with quantile plot. And there will be also another plot which is called Quantile-Quantile plot. Okay. So the quantile plot, we can see this is the plot to indicate the x value pair with frequency. Okay. So this is x is the value pair with the frequency, and it is approximately like 100% of the frequency. Okay, so maybe we can make the range of the value with the percentage. Okay. There is another kind of plot, we call it Quantile-Quantile plot or QQ plot. Okay. So we want to quantiles the one univariate distribution against the corresponding quantiles of another. So we want to check the quantiles of one data with the quantiles of another data. So we will see this example here, and we will check the correlated and uncorrelated data. So this is an example of the quantile plot. We have the unit price, let's say. This is the price. And then based on the F value, so we can make like the frequency, and then based on the F value, this is the most, the maximum 100. And then we can have this is in the Q1, and then this is the Q3. And then yeah, you can see if the 40 is the minimum and 100 is the maximum. Okay. So this is the maximum, and then this is the minimum. So this is the quantile plot. You can also see the quantile-quantile plot Suppose I want to check. Okay, so it is the graph, the quantiles of one univariate distribution against the corresponding quantiles of another. Let's say this one, the unit price of the brand number 2, and this is the unit price of the brand number 1. Maybe you have your company in one in USA and one in Korea, and they have a little bit different price. So you want to see the comparison. Okay, maybe the first product, they have the same range value, which is $40, but the maximum is a little bit different. Okay, so here the maximum maybe is about like 105 for the branch number 2, but for the branch number 1, the maximum value is 120. So using this kind of plot, you can understand the variation between branch number 1 and branch number 2. You can plot the Q1 and the median and the Q2. Okay. In the correlation, we will study more with other kind of method, but I would like to teach you only 2 here. The first is correlation analysis, and this correlation analysis is for the nominal data. Do you still remember what is nominal data? It is the text. Usually it is text, or it is qualitative, or it is discrete. Okay, we call this is the categorical data, and the formula is the observed minus by the expected value divided by the expected. Okay. And we can also use this for the numerical, but there will be another way. So let's just see how we can apply this for the nominal data. Okay. So the larger x, we call it, this is chi-square. Okay. So the more likely the variables are related. Okay. So the cells that contribute the most to the chi-square value are those whose actual count is very different from the expected count. So let's see how we can see this correlation. Okay. But I need to note to you that the correlation does not imply causality. For example, in one case, the number of hospitals and the number of car theft in a city are correlated. So maybe after I calculate the chi-square for these 2 data, the chi-square is high. So you can say that, okay, those data are correlated. But actually, it is not representing the causality. You can say, for example, is it because of the number of hospitals, the increment number of hospitals, it will increase the car theft? No. Okay, so there is no such causality. So it is just to see the correlation. Okay. Maybe, yeah, we can say that, okay, the population increase because the population the population increase, so the number of hospital increase, and also the car theft is also increased. So that can be the explanation. Okay. So let's see, in one example, okay, I want to toss coin. Okay, you have the coins, right? So in the coin toss, we can toss, for example, for 100 times. Okay, and I collect the data. I want to collect the heads and the tail. So this is the nominal data, and there are 48 heads and from 100 times, I got 48 times for the head, and I got 52 times for the tail. So how can I calculate the chi-square? So the chi-square is, for the head, we have the observation is 48, and the tails, we have the observation is 52. What is the expectation? Yeah, because it's coin toss, so I expect is half and half. So we can have 50 and 50. Then you can just put the number into this formula. 48 minus 50 is minus 2, and then 52 minus 50 is 2, and then you do the square, and after you do the square, you will divide with the expected value, which is 50. Okay, we get the 0.08, and the chi-square is the summation or sigma. So we have 0.08 plus 0.08, and the result is 0.16. So is it highly correlated between the head and tails? Yeah, actually no correlation, because the value is very small. What about another data? So it is more complex data. Okay. So we have, this is the observation. And then this is the expected value. Okay. I want to know whether someone who like science fiction, he also play chess. Okay. Or I want to know if someone likes science fiction, he does not play chess. So the number of observation, there are 200 data, 200%, but we expect 360. Okay, so we have the data of the observation, and we have the expected value. So we can just put the chi-square. Okay, so the 250 minus 90, 250 is the observation minus the expected value divided by the expected value. And once we put this into the equation, you can get the value is 507.93. Okay, this value is big. Okay, because it has a big value, we can say that there is a correlation between the science fiction and the chess. Okay, so we can just say like that, there is a correlation. There's another way to calculate the correlation. We call it, this is the person product moment coefficient. Okay, maybe because of the time, you will do the quiz in 1 more minute. I will stop first at this page. I will continue again after the break. Okay, so before you do the break,